All right, so now hopefully after watching that first video, you have a good understanding of what a vector is. So let's define it. So can anybody tell me from that video what is a vector? Will, what was that? Very good, a directed line segment. Excellent. So a vector is a directed line segment. What does that mean? Well, that means that it has direction and it's a line segment, so that means that it has a what? A finite length. Very good. What is going to determine that length is what we call the magnitude. So the magnitude is going to be a property of every vector, and the magnitude is what determines the length of the vector. So what I'm writing at the bottom there without talking, and that's awkward and silent, is that it's not necessarily a location. So yes, there is a location, but we're going to see that we can move vectors around within space in a two-dimensional plane, kind of where we need them, and it doesn't really change the vector. Before we see that, though, we're going to see that more in applications. Let's make sure we know some notation for vectors. So the first thing we want to talk about is some terminology. So here's a vector. I can see this is, I'm going to call this vector v, and it has what we call an initial point of p and a terminal point of q. So think of it as q is the arrow end, p is the non-arrow end. So that is giving it direction. So this is a point. So I can think of this as the point, coordinate point p1 comma p2, and I can think of this as the coordinate point q1, q2. And so I could call this vector PQ with the vector symbol. We won't really be using that notation that often, but that is something we want to understand. What we want to understand more, though, is what we call component form. So how do we come up with component form for a vector? So I can say vector v, if I'm using these points, would be the components. And so you use these angle brackets. So vector v would be the components q1 minus p1, comma, q2 minus p2. And so then if we actually did those subtraction, if we had numbers to put in here, then this would become v is v1, comma, v2. So these would be the components, and this is how we would get the component form if we knew the location of the points of the initial and the terminal parts of the vector. What does this look like? Anyone think about in terms of algebra? When we've done this sort of computation before, given 2 points, what are we kind of finding? Anyone? Come on, think about it. Sarah. Excellent. Slope. Exactly. This is like slope. And that's really what gives direction to vectors is think about slope. So then the magnitude, what is the magnitude? As I said before, the magnitude is the length. Therefore, it's always going to be a positive value. This is the notation for magnitude. It's these double bars. It doesn't mean absolute value. It doesn't mean double absolute value. That doesn't make sense. It is just these double bars in terms of vectors. That is the symbol for magnitude. How do we find the magnitude? Well, how do we find length? Great question. We already know that. We find length by using the distance formula. What is the distance formula? Just the Pythagorean theorem, but between 2 points. So we have the 2 points. So the magnitude of PQ is going to be the square root of Q1 minus P1 squared plus Q2 minus P2 squared. That's our distance formula, aka Pythagorean theorem. Great theorem. We could also, again, write this. Magnitude of V would be the square root of V1 squared plus V2 squared. where the v1 and the v2 are the components of vector v, which we get by subtracting the points. Excellent. Moving on, what about vector addition? Well, if it's in component form, vector addition is really, really easy to do. So if we need to add two vectors, and I have some vector v, which is v1 and v2 as components, and vector w, w1 and w2, those are the components. Just a side note, it's really important that we understand this bracket notation so that we know that this is the component form of a vector as opposed to a point. So points have parentheses, component form is the angle brackets, because it can be very confusing if we don't understand that difference. So back to vector addition, if I want to add vector v plus vector w, then I just add the corresponding components. So v1 plus w1 and v2 plus w2 would give me the new components of v plus w. If I was doing subtraction, same exact thing. You would just subtract the corresponding components. Vector multiplication. Well, right now we're just going to talk about scalar multiplication because there really isn't vector multiplication. There's like a dot product, and then later on there's a cross product. We won't do that in here. But we're going to talk about scalar multiplication. So if k is just a real number, and then I have some vector v, then the vector kv is called a scalar multiple of vector v. Remember, scalar, we've talked about this word before. It's come up in many other topics within this course. Scalar just means that we're scaling the vector. So that can be making it bigger, it can be making it smaller, depends on what that constant is. So the vector kv has a magnitude of the absolute value of k times the magnitude of v. That should make sense. We need that absolute value because k could be a negative number, but magnitude always has to be a positive value. The vector kv is going to have a direction that's going to be the same as vector v if k is greater than 0, and the opposite of vector v if k is less than 0. So this is where that direction part comes in. If we multiply a vector by a negative number, it changes the direction of the vector. Conclusion. Vectors are directed line segments. That direction comes from the components, and the length of the line segment is determined by the magnitude. They don't have to belong to a specific location. So again, we'll see this more in the application problems that we get to later, and it'll be important to be able to move the vectors around in order to actually do the algebra that we need to, or the arithmetic that we need to find out information about the application. It's important to understand the various ways to write a vector. Right now, we're just looking at component form. Keep watching the next videos, though. You'll find many other ways. Hope you enjoy. Have a good night.